Hey, what's happening, my crazy peeps? Today we're going to do some writing equations if we give you the roots. Okay, so give me an equation if I give you the roots. So let's start with a little review. Look at this simple guy here, x squared, 7x, and 12. Could you find the roots? I think easily, right? You would just, whoops, you would not do that. You would do this. Okay, cool. So set it equal to 0. This looks like an easy AM. X minus 4 and 3. Okay, solving each side for 0 because of that nice zero product property thing that we know about. These are the roots that we get. 3 and 4. Okay, easy enough, right? So the deal is, what if I were to give you those? What if I were to just give you 3 and 4 and say, you tell me where they came from? Well, that's what we're going to do. Let's first just take a look at these notes here. Very important that you do know this, that roots can be real or imaginary, rational or irrational, equal or unequal. And the degree of an equation determines how many roots you'll have. So x squared, you know you have 2. X cubed, you'll have 3. X to the 4th, you'll have 4, and so on. Okay, so that's that. But here's like the really big deal. Like, I'm being serious. This is very important. Imaginary and irrational roots, these guys come in pairs. Always. They're those conjugate pairs. Quadratics do have 2 roots, and you wouldn't tell me that these are pairs, right? 1 is 4, 1 is 3. Okay, that's because these are just rational. They're straight up roots. 3, 4, they're gorgeous. They're not crazy irrational numbers like radical 3 or 2.6059, whatever, These are beautiful. So they just come as they are. However, if you are irrational or imaginary, you'll always come in these pairs. Check this out down here. Just like the quadratic formula, right? 3 plus radical 7, 3 minus radical 7. It's really important that you know that those are conjugates of each other. And when your roots are like that, they'll always be in conjugate pairs. Okay, so that's that other important point before we start. Here's what someone's going to say to you when you're walking in Walmart. Hey, come here, aisle 6. I need roots 3 and 4, or I have roots 3 and 4. Give me the equation that they came from. You could work backwards, right? We could just say, if one of my roots is 3, thinking about the T-chart business, it probably came from these binomials. Okay. Then we can distribute, for sure, right? And wouldn't you know it, we'd come right back to where we started, which was x squared minus 7x plus 12. But if someone gave you these 2 roots, these beautiful conjugate pairs, what are you going to do? Like, it's a little ridiculous, wouldn't you say? Let me try something. God, I don't know. How do I minus that? So like x minus 3 plus radical 7. That would be my T-chart thing, right? And then this guy would be x minus 3 minus radical 7. I don't know. It sort of looks crazy at this point. So here's my 2 binomials. I don't know. Who's going to do this? That distribution looks pretty insane. So here's the quick way to go. And it's not just quick and it's not a trick. It's actually beautiful. But here's the math behind it. There's a way to write quadratic equations based on your roots, and it's right here. This is the key for today's lesson. You can always write a quadratic using its roots based on this idea that you would have x squared minus the sum of your roots, and put an x next to it, plus the product of your roots. So if you look at this 3, 4 business that we had from our beginning example, if we summed them, which just means add them up, 3 and 4 is 7. And then if we multiply them, we'd get our 12. Well, check it out. X squared minus the sum. Well, that's x squared minus 7. Put an x there. plus the product. Well, that's 12. And isn't that fast? And it's also very nice. Back to the crazy example. Look how easy this becomes, especially since they come in conjugate pairs. I can't stress that enough. The fact that they're conjugates makes this so easy. If you were to add these guys, this radical business disappears thanks to the conjugate. You end up with 3 plus 3 is 6. And radical 7 plus negative radical 7, well, they're gone. Isn't that awesome? How about the product? Well, if you remember dots and conjugates in general, the middle terms disappear. Minus 3 radical 7 plus 3 radical 7. And then radical 7 times radical 7 is negative radical 49. These go away. Thank you, conjugate. We're left with 9 minus 7, which is 2. Okay, so our sum was 6. Our product was 2. Now we just plug them in. X squared minus the sum, x, plus the product. Cool. So if you did solve this for the roots, x squared minus 6x plus 2 equals 0, you couldn't do any kind of factoring here, so you'd run over to complete the square or the quadratic formula, and you would get these roots. You would get 3 plus radical 7 and 3 minus radical 7. So this is a very cool way to find an equation given your roots. Okay, so let's move on. What about these complex businesses, right? How about this one, 3 minus 2i? Someone tells you, now this is the tricky part, someone says, hey, I've got a root and it's 3 minus 2i. You tell me the equation that came from. What I said in the beginning is so important. You must recognize that these will always come in pairs. So if someone's sneaky and tells you that one root is 3 minus 2i, you're going to know the other one is 3 plus 2i. So here's my first root. Here's my second. Okay? Now you're done. I mean, that's the hard part. Seriously, that's the knowledge you need to have, and you'll be very successful. Because at this point, you'll know, oh, I'll add them, I'll multiply them, and that's it. I'll have my quadratic. So let's do that. Now, it's important to know also, you can use your calculator for this stuff. So let me just bring up my TI calculator business here.
Ladies and gentlemen, it's going down! I'm yelling timber. I love that song. Anyways, we'll be landing shortly.
Okay, are you going to go crazy with this stuff by hand? Absolutely not. You go to mode, make sure you are in A plus BI. I know some of you saying that really doesn't matter. I figured out a way to break the calculator. But just to be safe, put it in A plus BI mode, okay? All right. Now it's as simple as this. Well, yeah. 3 minus 2i. 3 minus 2. The I is the little decimal point down there, just like the top of the I. Okay? Let's add that to 3 minus 2i. I did something wrong. Oh, Murray, you're an idiot. This is what I did wrong. One of them's got to be plus, right? Isn't that the conjugate? Wah, wah, wah. Okay. Bam, 6. Cool. Okay. So we add them up. Sum equals 6. Our product is going to come out of the calculator as well. Check this out. Maybe I can even use what I just did. I can. I'm going to delete this little plus sign. We're going to keep it into multiplication. Here we go. Delete. Phantasm. Hit enter. 13. So now we can plug it into what we know, right? X squared minus the sum, put an X there, plus the product. How cool is that? Piece of cake. And all you had was this to begin with. That's amazing. So, given a root, you can find its conjugate, then you add it, multiply it, plug them in, and you're done. Awesome. Next one. All right, this is supposed to be a hard class, right? So what if it's third degrees, like this stuff? What if it's that? Well, It's just going to be more legwork. It's not any more complicated. It's just a little bit more math. Now, again, back to the beginning. If someone told you the roots are 3 plus 2i and 5, huh, well, this and this, those are not pairs of each other. They're not conjugates. So what you need to realize is, okay, root 1 is going to be that. Root 2 will be the conjugate pair. And then this third guy over here, root number 3, will be 5. But 5 doesn't come with a pair because it's rational. If it's a beautiful number, it's just a single root. You don't have to go finding another one. So apparently there are 3 roots to this equation that we're about to find, and that would tell me that it's probably x to the third, because the highest degree tells you how many roots you can expect to have. Now, whether or not they're crazy roots or rational roots, that's a whole different story. But you are definitely looking for 3. Okay, so to save some time, we already did this, right? That was in our last slide. And the solution to that was x squared minus 6x plus 13. So now what? Well, let's take 5 and make it like our t-chart. If one of my roots is 5, remember from the beginning, that means it probably came from x minus 5 as one of the factors. What do you have to do now? Well, we're going to have to do this. We're going to have to distribute the x. If you'd like to use a box, you can. The box method, that's fine. But whatever you do, this is what's going to have to happen. We're going to have to combine like terms and so forth. Okay, so I have a little cheat sheet here, and I know that the answer is going to look like this. When you do the distribution, this is what you should get. And I'll go full screen, sorry about that. Okay. Okay, combining like terms. There you go. Nice. Given roots, this and that, remember that these come in pairs, these do not. So I'm looking for 3 total. That means my answer should have x cubed. That's a good little safety check right there, and you're good to go. Let's go to the next one, which is even harder. How about a 4th degree? How do I know that this is 4th degree? I have 2 roots. Wouldn't you just say that that's a squared or a 2nd degree, right? Well, now you're so smart. You realize that these are irrational, so they must come in pairs. So here's root number 1. Here's root number 2, the conjugate. Over here, root number 3, and root number 4, the conjugate. Okay. If we add them and multiply them, this is what we'll get. The sum of those is 4, and the product is negative 2. If we do these guys, the sum will be 10, and the product will be 18. So that's telling me that this one is going to be x squared minus the sum with an x plus the product. This guy is going to be x squared minus the sum plus the product. Oh my. Now this is a disaster. This is a lot of work. This may be where the box method actually is a little nicer than the way I always do it, because you're looking at a 3 by 3. We need to distribute these guys like crazy, okay? Oh boy. I have the answers here written down, so I'm going to be able to go pretty quickly. I'll try to color code them for you just to keep you straight. So I'm going to go there, there, and there in red. Okay, and what I will receive is this. No, that's wrong. Sorry. Okay. Oops. Then I will take green and do this. I'll take black.
All in black.
And do the last one. Okay, let's combine like terms, and the winning color will be, I don't know, purple. Purple's cool. Okay, if you combine all like terms now, this should be your final answer. X to the fourth minus 14x cubed. Can't read my own handwriting. Looks like 56x squared. 36. And that should have been minus. Hang on a second there. I can hear you screaming already. Okay, and equals 0. Cool. So does this make sense to me? Yes. Why? Because I look here and say, all right, I've got a 4th degree and I have 4 roots. That makes sense. You know, just a simple way to check yourself to make sure you're on the right track there. The math here, I think, is pretty straightforward. You just have to remember that roots come in pairs, and you can always write a quadratic as x squared minus the sum plus the product. Okay, fantastic. So let's see what else we have. Oh, just a recap, which I think I just did. So I hope you enjoyed this video. You have an awesome night, and Zanfini and I will see you in the morning. Okay, take care. Bye.